Hi all, thanks for welcoming us at the DMS. I will present you a few projects which has been made on lattice structures. 3 projects which has been made in collaboration between Erde and Bollinger Grohmann those past 10 years. So here you got an image of this kind of structure. So it was made in Paris in 2009 for the Hermès flagship store, Rue de Sèvres, there. And as you can see, it's composed of wooden bubbles, composed of double curved wooden lath. And there are freestanding elements. I mean, the cables you can see on the top are just a suspension of the lighting. They are not connected to the structure. So I will present through those different projects 3 main aspects: the design development stakes, the fabrication issue, and the design workflow ones. So just a short introduction about those 3 projects. So the first one is Hermès Rive Gauche, that you can see on the left. The second one is Hermès Moscow on the Goom. So it's composed of a railing made of double curved unique pieces. And the last one is a private pavilion in Cleveland used as a piece of art for a private client. So first I will present the different aspect which has been made from the beginning in collaboration with the architect. So what we basically got from the architect are those intentions, but which have to be improved and implemented with different type of constraints. And one of the main one is a generation of the surface and the tessellation. So a great job has been made from the beginning to regenerate those master surfaces in function of different parameters, aesthetical ones, of course, but structural ones, others connected to fabrication. One of the main issue was the curvature. So as explained previously, the thinner the wooden plate, the thinner the radius of curvature, which on those pavilion was an important stakes. For those lath here, for example, you can see lath from the pavilion for the railing in Moscow. There are 6 meter long lath with radius of curvature which are less than 80 centimeters. So for those elements, we distinguish the different curvature and the torsion which were implemented from the beginning into the model. So those are kind of studies on these curvatures, which has been made from the beginning till the end through a unique global model. So when taking into account those considerations, those different constraints, we were also designing different possibilities for the pavilion, different type of tessellations. So basically, one of the main tessellation which has been made in Hermès Rive Gauche as in Cleveland was just a splitting of the surface with 2 generator curves divided into points and then connected through curves. And then those points are shifted along the curve as you might generate an hyperboloid from a cylinder. And then a tessellation has been applied on it, taken into consideration. So as I said, curvature issue, but also aesthetical one with the density. And has been improved and evolved in the model through parametric softwares. So here you can see on the left pictures, so the work on the density with the number of rods, the rotation around the central space, and also the spread on the density, as the architect wanted something, a pavilion which was lift up with a very vertical fit and a high density on the top level. All of those work has been made taking into consideration the other parameters. One of the main other parameter was the structural one. So as you might know, this kind of structure might need wind bracing, which here in SAVE were placed on the top, but other options have been improved for the other pavilion. So if we take into consideration just the connection details, so which was made with 3 rods. So the main one, the central one, is just here to handle the shear force between 2 lathes, but the 2 extreme ones are here just to block the rotation between the lathes themselves. But the bigger the angle between the lathes, the thinnest the distance between these 2 rods. And then the thinnest the connection stiffness for blocking the rotation. That's the reason why in the pavilion of Cleveland, this angle has been taken into account in order to implement the connection stiffness during all around the different type of connection. So also the stiffness is quite low. Here we are speaking about a distance between 2 bolts of a few centimeters. The large number of them, there are around more than 1,000 connections. It can handle the different loads. So for the pavilion of Cleveland, which was placed outside, so submitted to variation of temperature and humidity, a finished approach on those loads has been made with an approach on the load and snow accretion placed on top of the pavilion. As you can see, it's still standing. Another main issue was the fabrication once, which has been tested on different pavilions. So just a first element about the type of roots that here we were using ash tree and oak tree for the project of Hermès Rive Gauche in Moscow. But as the pavilion of Cleveland was placed outside, for question of durability, a special type of wood has been used, which is Akoya. So it's a specific treatment on the timber in order to preserve it. And it was the first time this type of wood has been placed with, has been used with this type of bending process. So that's the reason why different tests has been made on it. So about the processes of fabrication, one could say, okay, let's mill all those pieces and then stick them together, as you can see on the left. But then you will face different troubles as structural issues, but also aesthetical ones of the discontinuity of the fiber. So that's the reason why other processes has been used. So the first process which has been used in Hermès Rive Gauche was the use of 3 layers of lath, which were milled from wooden plate in order to obtain the first curvature. Then those layers were glued while bended in order to obtain the second radius one. So here you can see an example of the prototype from this pavilion. Another technique which has been used, as you can see here, was the use of small square section, allowing small radius of curvature in both direction without taking into consideration troubles due to a variation of fiber orientation. And here you can see some pictures of the fabrication. So the lath are glued and placed on the scaffolding. For each lath, approximately 6 people were needed at the same time, so quite long. And here you can see the scamp on the lath. They are placed every 10 centimeters during the fabrication. And so then lath were disassembled. The connection been prepared and then disassembled to be sent 6 times. And then the scaffolding and the lath were shipped and reassembled in the pavilion, erected. So here you can see some pictures of the finishes pavilion. One aspect from this was the scaffolding issues, which has been improved for the Cleveland pavilion, where the scaffolding, which is carrying the whole intelligence of the shape, because it's a support of the slab while bending, here was only made with straight pieces with rod placed on it in order to have a proper control of the geometry. One other issue was also about the connection, how to produce kind of unique or semi-standardized element. So for Hermès Rive Gauche, for example, the feet were still placed, welded with 3 different angles and incorporated in the slab, which has been changed in terms of process for the one of Cleveland with tubes in the continuity of the lath. Then just a few words about the design workflow. Yeah, I would like to thank all those our collaborators, which have made a really great job in this pavilion. But I want to focus on one specific point, which is the use of a global model generating from the master surface given by the architect through the tessellation, the analysis of the different elements, the curvature, the structural model, the setup of all the different detail till the fabrication of the pavilion and of the scaffolding. And so this took place from the very beginning of this project. For Hermès Rive Gauche, in 2009, it was used a Rhino script specifically made for this project, connecting through Excel sheets the 3D model to the structural ones and generating the double cubed lath. So yes, it was this idea of having one unique model generating all the elements we got. Yeah, for the details, the possibility of shipping, the structural elements, the interaction between the environment and the production. And it has been illustrated in the project of Moscow, where this cladding is loving a central stairway. But this stairway has been made quite early and has been changed several times. Steps have been cut out and replaced and then extended several times. That's the reason why this model, which taken into consideration the very input from the architect and giving the last result, was kind of a very useful tool for the conception of this railing. So yeah, here is a support of those double curves, so which have evolved. And as you can see here, for example, it's a detail of the railing where specific diagrams were directly extracted from the Rhino model, just in order the geometry of the railing. So this railing has been ruled by per different laws. So the distance to the railing, the distance to the step, the height of it. So that's the reason why, with a very narrow and constrained site, this model has been a very useful tool. And finally, the client seems happy about the result. So those double curved elements. Yeah. So I wanted to conclude by just saying that through all this project, we have been the influence of the complexity into the 3D model. But at the same time, it seems that the complexity is shifting into the design and allowing less complexity in the fabrication part, as no milling machine has been used for this Cleveland pavilion. Thank you.